Acha, so we were discussing classification and regression trees last time. So there were only a few things that were left that we still needed to discuss. First of all, जो है, what are the different advantages for of this algorithm, and also the shortcomings. So we'll continue with this today, and then we'll move on to some clustering algorithms, and I hope we'll be able to complete this today. So that in the next session we have some extra time for the last quiz as well. Or हम फिर कोई questions आपके वो भी address कर सकें. So there's this person named Pashma Said. Can anyone tell me who this could be?
Sir,
She's
ये
from academics.
academics हैं.
Okay, all right. Sorry. Okay, so first of all, some advantages. So it's a classifier that actually does work on most of the problems, and it's relatively it's a relatively simple algorithm, and it does well on many problems. It can handle both numerical data and categorical data very well. आपको बहुत ज़्यादा कोई इसमें pre-processing की as such ज़रूरत नहीं होती. Numerical
Okay, sir.
variables को आपको कोई categorical में convert नहीं करना पड़ता. Yes, somebody asked something.
Yes, sir. Sir, मैंने कहा कि ये session last नहीं है.
This is our 29th session. So the next one is going to be the last one. Remember we missed one session दरम्यान में.
ठीक है. तो सर आप इसी वीक उसे मेकअप कर सकते हैं. Saturday तक कर लें बेशक.
Is that necessary?
Actually सर वो cover हो जाएगा ना सारा इसी वीक. फिर हम free हो जाएंगे next week में.
But you still have a lot of time until the final exam. Final exam अभी June के end पे होगा earliest भी. So there's still a lot of time.
चलें ठीक है.
There's actually going to be a quiz in the last session, so I also want to give you some time to prepare for that. तो आपके पास 2-3-4 दिन तो हो at least.
चलें ठीक है सर.
ठीक है.
Okay sir.
So it will be our regular time. That's on Monday. ठीक है. Okay, so there's somebody here who is unmuted. I can hear their voice. Okay. All right, so then you have this very important thing कि जो आपके अगर algorithm में आपने input में if you have just input passed on all the available variables that you have, तो अगर उसमें कुछ variables जो हैं unimportant भी हैं, आपका algorithm उसकी वजह से जो है इतना effect नहीं होगा. So the cursive dimensionality वाली problem है, which is very important in k nearest neighbors and some of the other algorithms. यहाँ पे decision trees में it does not have a lot of impact because remember the way the algorithm is designed is कि सबसे पहले वो important variables को जो सबसे ज़्यादा important variable होगा it's going to split on that variable first, and then it's going to go to the next important variable, and then to the next important variable, and so on. So the unimportant variables even if they come into the tree, they're going to be at the very end. So the pruning wala step hoga, that will automatically leave all of those variables out. So the unimportant variables, even if they're passed into the algorithm, they do not cause much of a problem in case of decision trees. And then decision trees also work well on small data sets. So in many machine learning algorithms, जो थोड़े से ज़्यादा complex होते हैं, they require large data sets. In fact, most of the non-parametric methods, जो ये भी decision trees is also non-parametric. Most of the non-parametric methods require large data sets. Decision trees में it also works fairly well in small data sets. And of course, जब data बड़ा होता है तो it scales well as well. Now, there's a slight distinction here in terms of the interpretation as well. We discussed earlier that the non-parametric methods we cannot generally interpret them very well because आपको जो है एग्जैक्ट फंक्शन नहीं पता होता जिसकी बेस पर जो आपका रिलेशनशिप है बिटवीन द इंडिपेंडेंट वेरिएबल्स एंड द डिपेंडेंट वेरिएबल्स. हाउएवर, in case of decision trees, even though it's a non-parametric method, आप थोड़ा बहुत जो है as in you can do some partial inference in the sense कि आपको ये पता चल जाता है at least कि which variables are more important. ठीक है, that much inference you can still make here. और आपको path भी पता चल जाता है. For example, you can आपको अगर देखना है कि how is the tree predicting a certain value, in most of the non-parametric methods, you would not be able to figure that out. But in decision trees, you can actually follow that exact path that you follow in order to get to that outcome. For example, आपके पास tree को आप visualize कर सकते हैं. You can see कि अच्छा अगर ये outcome है, तो वो कौन सा path follow करके कौन से variables को जो है उसमें को use करके उसने वो final prediction दी है. So you can interpret it in two ways. The first is you can figure out कि आपके important variables कौन से हैं, सबसे ज़्यादा important variables कौन से हैं, and you can sort of sort them in a way from most important to least important. And the second thing is you can identify for one particular prediction के वो किस वजह से जो है आपने उसको वो certain category जो है या certain value जो है at the end वो assign की है. So this is very important when I show you some of the real life applications that it's used for. This point is very important for that कि आप उसको थोड़ी बहुत आप इसमें interpretation कर सकते हैं. And then it can handle missing data very well. अगर आप उसको आपको पहले से उसको treat नहीं करना पड़ता. You don't have to necessarily assign those missing values पहले से. Decision trees automatically if you have for a particular predictor for a particular node अगर उसके अंदर कोई missing values हैं, it will just ignore those values for its calculations. जब वो split कर लेगा तो whatever those missing values were, it's going to assign those values uniformly to all the children of that node. तो वो missing data वाला problem भी यहाँ पे it can handle itself. But then there are some disadvantages as well, at least in the most basic of decision trees. हमने एक basic algorithm देखा था कि based on the distances वो किस तरह से decision tree form होता है. तो it has a problem of overfitting and underfitting. अगर आप pre-pruning for especially अगर आप देखें तो you can end up having underfitting in that case. And if you do not if you just keep on growing the tree until it classifies everything या फिर आपके number of features जहाँ तक खत्म हो जाए, you can have this case of overfitting. तो उसको handle करने के लिए we have to use certain methods like post pruning, and then you also have some of the other methods that we have not covered in our course, but the extensions that I showed you, like bagging and bootstrapping, random forests जो है, if you explore it further on your own, you'll figure out कि इस तरह की problems address करने के लिए we use some of those methods in practice. And then there are some other disadvantages. आपके अगर large trees हैं, अगर trees आपके बहुत बड़े हो जाते हैं, this interpretation is not very easy in that case. अगर आपके trees बहुत बड़े हो जाएं. I have some questions here. No, Azhar, we do not necessarily need large data sets for decision trees. It does work fairly well on small to medium sized data sets as well. I thought it was only for parametric. Azhar, I don't understand your second question. Sorry, could you repeat that? Azhar? Okay, your mic isn't working. Okay, let's address this towards the end then. Some of the real life applications that it's used for, so medical diagnosis. So if you have, let's say, different variables, it could be the different symptoms that a person has, their test reports, and a lot of other things. They could all go into this model, and the model could be helpful in some medical diagnosis. And then you have its application in this loan applications thing. Okay, if a person were to apply for a loan, you could use such algorithms to basically predict how likely it is that the person would return the loan, and whether they would return it in time. uh, the interpretability of the decision trees is very important here, because remember we discussed this earlier in some other part of the course as well. I don't remember where. That uh, especially in such applications where you are uh, making a decision of whether to give loan to a certain person or not, you have to be able to justify your decision as well. Especially in Western countries, the laws are very strict that if you deny a person a loan, you have to be able to justify. You have to have a reasoning for that. तो अगर आप इसके अंदर कुछ ज़्यादा complex models use करते हैं, for example, there's some models like neural networks, support vector machines. उसमें you cannot really say anything about कि आपने जो आपका model अगर ये कह रहा है कि you should not be giving this person a loan, you cannot really justify that, because आपको नहीं पता कि वो मॉडल ने क्या क्या चीजें, क्या वेरिएबल्स यूज करके या क्या 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 फंक्शन यूज करके वो फाइनल आउटपुट जो है वो फाइंड किया. बट इन केस ऑफ डिसीजन ट्रीज, यू कैन शो एग्जैक्टली the steps that the tree that you have followed on the path to reach that particular outcome. So you can say कि अच्छा ये important variables थे और ये variables जो थे इसमें this person was coming out unfavorably, तो उसकी वजह से we had to reject the application. So the interpretability is very important there. And then in manufacturing control, so basically, if you have different manufacturing processes, तो उसमें भी decision trees, अगर आपको कहीं पर जो है, if there's a fault somewhere, your decision tree is able to you can actually follow the path on the decision tree and find out कि अच्छा क्या क्या चीजें जो है वो exist करती हों, तो there is a possibility of having a fault somewhere. So again, the path that you have on the decision tree is very important. So just to emphasize that point, let me show you one of those trees that we had here. So for example, यहाँ पे, if you are predicting a critical success, जो हमारे movies वाली example थी, you know exactly कि आपने एक critical success कैसे predict किया. You predicted a critical success. You predicted a particular movie to be a critical success. Why? Because it had a high number of A-list celebrities, and then it had a low budget. So based on this path, you said, okay, this movie is going to be a critical success. So the trees can be interpreted like this कि आप exact वो path आपको पता हो सकता है. And the second thing is also कि जो variables ऊपर आते हैं tree के अंदर, for example, the number of A-list celebrities in this case would most likely be a more important variable in the prediction as compared to the estimated budget. So जितने आपके variable जो है ऊपर होता है आपके model के अंदर, उतना ज़्यादा it's considered more important. Acha. Let me come back to that question. Azhar, could you elaborate on that question so we can I can quickly answer that and we can move on to
the clarify हो गया मुझे.
Okay, हो गया. Okay, good. Your mic is also working now. That's good. So let's move on unless we have any other questions on this. So any questions on what we've discussed here? So the quiz in the next class is going to be on the decision trees algorithm and the KNN algorithm. So you need to be prepared on both of these algorithms. I have not uploaded these slides yet. The video is already uploaded, but I'll also upload the slides before, in fact, right after today's class, inshallah. I'll be uploading the slides as well. You can have a look at this. And the last thing that we need to discuss in our course is some of the clustering algorithms. They're fairly simple. Should not take too much time. So I'll move on to them now. Okay, so I hope you can see these slides. Okay, so first of all, here we're going to be talking about some clustering algorithms. Okay, so uh, this is a part of unsupervised learning algorithms. अभी तक जो हमने जितनी भी चीजें की हैं, in all of them, what we were doing was supervised learning. Okay, so this is different from everything that we have covered as far as the machine learning portion of the course is concerned. This is different from that. How is it different? So remember, supervised learning may you always have two types of variables in your data. So we have some input variables and you have an output variable. Okay, and your goal essentially is to predict that outcome for the new data that you would have in future. The goal in this particular case, when you're talking about clustering, is relatively is different in this case, and the data input that you would have is also going to be different. In the sense कि आपके पास जो variables होंगे, you're going to have only one type of variables, and that's going to be input variables. ठीक है? You're not going to have any output in this case. आपके पास सिर्फ एक set of inputs होंगे, and you'll have to somehow group your data into different parts, into different segments. So let's say you have 100,000 observations in your data, and you want to figure out ki, acha, which of those observations are similar to each other. So you may end up grouping them, let's say, into 3 or 4 different clusters, into, let's say, 10 different clusters based on how similar those observations are. So that's basically the goal here, कि आप data को cluster करना चाहते हैं into different sections, right? So there are a lot of different things that this thing is important for. For example, the most important thing that you would encounter if you're talking about if I talk about the business school graduates here, it's going to be customer segmentation, market segmentation. How you can segment your customers into different segments, and you can target them separately in terms of your marketing. तो आप किस तरह से जो है हर different segment को different तरह से market कर सकते हैं. So there could be different types of customers, like new customers, and then you have some core customers. You could have low value customers, high value customers, some customers that you had in the past, but now they're dormant. They're not coming to your store anymore. So there could be different kind of segments depending on the data that you have. And then you have some other things like you could have so there's an example here. There's a company called Nielsen, and they do different types of market research. In the US, for example, what they do is they have information on almost all the citizens based on some publicly available data. And what they do is they try to cluster those people into different segments, and based on the information available, for example, their location, their gender, and any other publicly available information. For it could be their education, it could be some other information. Based on that, they sort of cluster those people into different segments, and then they sell this data to different companies that use this information for their marketing purposes. So this is called market structure clustering. Then you can, for example, if you can cluster different companies, the different types of companies. You could have tech companies like Amazon, Google. You could have oil and gas companies. You could have consumer goods companies. So basically, clustering refers to different groups कि आप किस तरह से किसी भी चीज को different groups में divide कर सकते हैं, ठीक है? So that's basically the idea. Now there are some things that you're going to need for the clustering algorithms. Some of these things are what we've already discussed before in some of the other algorithms. For example, you should remember this from the KNN, the K nearest neighbors methods, the similarity measures, your distance measures. So you need to know about the Manhattan distance, Euclidean distance, कि आप किस तरह से दो different observations के दरम्यान में distance find कर सकते हैं कि वो कितना जो है एक दूसरे से different है. और इसी तरह से आप इसको अगर जो है दूसरी तरह देखेंगे, it could also be considered similarity measure कि जितना ये distance कम होगा उतना ज़्यादा जो है वो दो observations एक दूसरे से similar होंगे, right? So this Euclidean distance we said is something that's most commonly used for numerical variables. So you should know about this as well. And then there's also another type of measure that we did not discuss earlier. You do not need to know what exactly this formula is about, but if you have a general idea about correlation, the management the management school students would at least know about that. Correlation is basically in fact, I think all of you should know about this. This is simple statistics. आप लोगों ने CS वालों ने CS वालों ने भी statistics के courses तो लिए होंगे, I'm sure. So correlation basically is whether two variables are moving in the same direction as well. So if you have two variables and they have a direct relationship with each other, that means if one variable increases and the other also increases, or if one decreases, the other also decreases, that means they have a direct relationship. इसको हम कहते हैं it's a positive correlation. And if they're moving in the opposite direction, एक increase होता है या तो दूसरा decrease होता है, or the other way around, that means they have a negative correlation, right? So there's another measure that's based on the correlation, and the idea here is if there are two observations and if they have many variables that are moving in the same direction, this measure is going to be so depending on ये आप किस तरह से use करते हैं. अगर इसको हम distance measure के तौर पे use करते हैं जिसमें हम 1 minus ये correlation measure use करते हैं, तो जितना ज़्यादा जो है ये number high होगा, that would mean कि आपका उतना ज़्यादा जो है वो observations different है. जितनी ज़्यादा number कम होगा उतना उसका मतलब होगा उतना ज़्यादा ये observations similar है. अगर आप ये 1 minus वाला part हटा देते हैं यहाँ से and you only think about this thing that you have inside here, this actually comes from correlation formula. इसमें जो है जितना ज़्यादा ये एक तरह से similarity measure बन जाएगी कि जितना ज़्यादा ये correlation measure जो है वो high होगा, उतना ज़्यादा आपके observations similar होंगी. जितना ये number low होगा उतनी observations जो है वो एक दूसरे से different होंगी. But again, you do not need to know too much mathematical details here, but you should understand this graph at least, and कि वो आपको बताते हैं कि आपके पास दो different types of distance measures होती हैं. One is this norm based measures, जहाँ पे आप distance calculate करते हैं between observations, and the other is this correlation based measures जहाँ पे आप देखते हैं कि उनकी direction similar है कि नहीं है. How are they interpreted differently? आप देखें, let's say you have 3 different customers. So you have this shopper 1, you have shopper 2, you have this shopper 3, and this is how their purchase amounts vary. So let's say they come to a store and they buy different things, and this is what their purchase amounts. In fact, let's say this is not item number. Let's say this is one transaction that they're doing at the store. So let's say they're doing different transactions at different times. And this is how the purchase amounts of those transactions is varying, right? So this is how shopper 1 is spending. So this is the highest spender in terms of the purchase amount. And then this is how shopper 2 and shopper 3 are varying. So if you were to consider how similar these customers are, which customers do you think are most similar to each other? Anyone who would like to respond to that? Which customers are most similar? Anyone?
Shopper
Sir?
1 and Shopper 2.
Okay, so Usama said
Sir?
shopper one. Ji Azhar. Okay, so Usama says shopper one and shopper two. So how are they similar? Usama, can you elaborate on that? Okay, so Fatma and
सर
Javeri are.
पैटर्न की वजह से,
Ji Usama?
उनके पैटर्न की वजह से.
उनके पैटर्न की वजह से. Okay, so shopper one and shopper two are similar in the sense कि their pattern is very similar. कि पहले जो है उनके start में amount low है, and then both of them spend relatively more at the second time. Then the spending reduces a bit, and then it reduces more. So इनका pattern जो है दोनों cases के अंदर it's very similar, right? Now, if you were to use the correlation based measure, ये आपको क्या बताएगा? ये आपको shopper one और shopper two को similar बताएगा because their trend is very similar, the pattern is very similar, right? But if you were to use the norm based measure, and that is going to tell you that shopper two and shopper three are very similar. Why? Because इनकी purchase amounts are more closer. So अगर आप यहाँ पे देखें इसकी purchase shopper two और shopper three की purchase amounts देखें और shopper one और shopper two की purchase amounts देखें, you would see कि 2 or 3 are more closer to each other as compared to 2 and 1. So if you were to use norm-based distance measures, that they would tell you कि shopper 2 or shopper 3 जो हैं वो ज़्यादा similar. So again, it's going to depend on what exactly you want as the output. क्या उसके ऊपर depend करेगा कि आप कौन सा distance measure use करते हैं. For example, if you were to segment in terms of the high value customers and low value customers, norm-based distance measures would be the way to go, because in that case you would be expecting कि shopper 2 or shopper 3 जो हैं they are relatively low value customers and shopper 1 is high value customer. तो अब ये दोनों ज़्यादा similar होंगे. लेकिन अगर आप जो है segment करना चाहते हैं in terms of their behavior, कि how are their spending amounts varying over time, that would in that case you would prefer using correlation measure. अगर आपने उस base पे segment करना है तो आप correlation measure use करेंगे. ठीक है? So it depends on the context कि आप कौन सा distance measure जो है use करते हैं. Then again you will also need to do scaling. In this case आपको standardize करना पड़ता है data को, because again if you have some variables which have a very large range of values, they might outweigh the other variables because of their simply because of their numbers. कि वो इतने large numbers है, अगर आप ये वाली distance measures use करते हैं इसमें जो ज़्यादा वैल्यू कोरिलेशन बेस्ड मेजर में तो इतना इफेक्ट नहीं पड़ता वैसे, लेकिन जो ये वाली मेजर्स हैं यूक्लिडियन डिस्टेंस, मैनहट्टन डिस्टेंस, इसमें आपके जो है स्केलिंग के बगैर इट्स गोइंग टू बी वेरी स्क्यूड और आपको results जो हैं they are not going to be very good. So you first need to scale your data. We have discussed min-max normalization and z-score normalization. So min-max आप तब कब use करते हैं? When your data is roughly uniform and you do not have you do not have any outliers in your data. And if you do have outliers, then you would instead prefer to use z-score standardization or z-score normalization. So we have discussed these approaches earlier. So they work here as well as it is. Then there are some other measures for categorical data that we have not discussed before that you should also know about. कि categorical data में हमने पहले तो ये हमने देखा था कि k nearest neighbors method में हम यही कर लेते थे कि अच्छा we could assign them values of 1 and 0 if they are binary variables, if they are categorical variables उसके हम dummy variables create कर सकते थे, and we could use the same distance measures for that. But what if, so let's consider, for example, some results of a survey, for instance, where you have outcomes of yes and no, you only have binary and categorical outcomes. उस केस के अंदर अगर आपने अब कस्टमर्स को लेट्स से आप जो है कोई कस्टमर सर्वे कर रहे हैं एंड यू हैव अ लॉट ऑफ डिफरेंट रिस्पांसेस टू योर सर्वे, और इसमें जो मेजॉरिटी ऑफ योर वेरिएबल्स जो हैं वो जो है वो है कैटेगोरिकल वेरिएबल्स हैं, ठीक है, या फिर डमी या फिर जो है बाइनरी वेरिएबल्स हैं, यस एंड नो आंसर्स हैं या फिर डिफरेंट कैटेगोरिकल आंसर्स हैं. उसमें कैटेगोरिकल रिजल्ट्स को भी आप ऑफ कोर्स अगर आपको यूज करना है तो आप जो है उसको डमी वेरिएबल्स के थ्रू यू वुड बी कन्वर्टिंग देम टू बाइनरी वेरिएबल्स एज वेल. तो उसमें those distance measures that we discussed earlier may not work very well because वो 0-1 values होंगी, तो उसमें आप जो है वो those distance measures may not work very well in absence of any numerical variables. So we have two other measures that are commonly used. One is called matching coefficient and the other is Jacquard's coefficient. हम पहले matching coefficient देखते हैं. So those of you from BSMT, you might remember this from our marketing analytics class as well. We have discussed them before, but for everyone as a review and for those of you who have not covered this before, let's try to understand what it means. Matching coefficient. So let's say you have a variable. In fact, I would say, again, let's ignore this formula for now, and let's look at, okay, so let's actually look at the formula first, and then I'll move to another screen. So matching coefficient, basically it's a very simple idea. Let's say आपके पास दो observations हैं which have different, you have two observations x and y, right? X is one observation, y is another observation, and you have a number of features, a number of variables. So let's say you have m different features, right? Plus m number of variables. Now, the matching coefficient, what is it going to do? So remember, it works when all of your variables are categorical variables or binary variables. What you're going to do is you're going to figure out कि कितनी जो हैं आपकी variables एक दूसरे से match करते हैं. How many of them are equal to each other, right? So for example, let's say you have 100 different variables, right? Now, let's say out of those 100 variables, you have 100 variables for each of those two observations, right? दो observations जिनको आपने आपस में इनका जो है distance measure करना है, एक similarity measure करनी है, दो observations है, and you have 100 different variables. Now, let's say out of those 100 variables, 15 variables have the same value for each of those two observations. ठीक है, 15 ऐसे हैं जिनमें same values आ रही हैं, and you have 100 total observations, 100 total variables. Sorry. Matching coefficient is going to be the number of variables for which you have equal values, right? So xj equals yj here means कि जब जितने variables की जो हैं वो same values आ रही हैं. So 15 variables have the same values for those two observations. So 15 आपका यहाँ पे numerator में आ जाएगा, and the denominator is going to be the total number of variables that you have in your data, right? Now let me show the same thing using this example here. Let's say you have a data set like this. आपको Excel sheet नजर आ रही है यहाँ पे?
Yes, sir.
Okay, so let's say you have this data, you have 10 different variables, and you have two observations जिनको आपने आपस में compare करना है. Of course, you could have many more observations, और आपको pairwise distances या similarities find करनी हो सकती हैं. So we are considering one case जहाँ पे आपने दो observations को आपस में उनका distance measure करना है, similarity measure करनी है, right? So there's one similarity measure that's called matching coefficient. ये आपके पास 10 variables हैं which are taking different values. So they're taking values of 1 or 0. मैचिंग कोएफिशिएंट इज गोइंग टू बी कि आप देखेंगे कहाँ पे इनकी सेम वैल्यूज आ रही हैं, राइट? सो for the first variable, the observation 1 is 1, observation 2 is 0. So यहाँ पे तो same नहीं है, so we do not count this. The second variable, this is we have the same value here, so we have first same value. Here we have both zeros, so we have the second same value. So 2, third same value, fourth, fifth, sixth, seventh, right? So we have 7 cases here जहाँ पे दोनों variables की जो है same value आती है, right? So matching coefficient is going to be 7 in the numerator. In fact, let me just write it down like this: 7 in the numerator, and then divided by the total number of observations we have here, that is 10. So it's going to give us 0.7 as the result, right? 0.7 as the result from 7 out of 10 here, like this. ठीक है? So matching coefficient क्या होगा? जितनी observations match करती हैं divided by the total number of observations. But the problem here is that it's giving equal weightage to 1 and zeros here. It might work perfectly fine for many cases, but there could be some cases जहाँ पे you may want to give more weightage to ones as compared to zeros. So for example, let's consider this case. Okay, you are doing a survey trying to so you work in the automobile industry and you are doing a survey with respect to the cars that different people own, right? Now there could be one question where you ask whether a particular person owns this car. I'm not sure how we pronounce this. Is this Corvette? So let's say a person whether they owns this car, right? So that's the question. So now it has a yes or no answer, right? The yes would be classified as a 1, no would be classified as a 0. Now if two people, they both own a Corvette. Now it does not seem to be a very common car, so it's a very it's a car that you would rarely see on the roads. So you can expect when you have two people who both own Corvette, they would be similar to each other, right? If there are two people who both own this particular car, they could be classified as similar to each other. However, if there are two people who both do not own this car, so that would be I will assume all of us, right? All of us in this class, all of us do not own this car. We would have a 0 in our case there, okay? That this variable would be 0 in that case. Now, the matching coefficient is going to say all of us are similar because we do not own this car, right? Now, we could have all of these other possible cars, but we do not own this car. The matching coefficient would say we are all similar because we do not own this car. Based on this variable, हम जो है वो similar classify होंगे. In this particular case, that's not a very good idea. What you would want is कि आप 0-0 वाला जो case है उसको आप similarity count नहीं करें. That's where this second measure comes in. That's called the Jacquard's coefficient. It works well for binary data generally, where you would expect the ones to have more weight कि आप सिर्फ दो variables को तब दो observations को तब similar classify करेंगे when they are both ones. However, they will not be considered similar when they're both zeros, right? Let's see how this formula works, how this coefficient works using the same example here. So we have two observations and we have these 10 different variables. In this case, जो 0-0 वाला केस है ना, we are just going to ignore that case. हम उसको numerator में भी नहीं consider करेंगे और denominator में भी नहीं consider करेंगे, right? So similarity के case के लिए हम क्या करेंगे, we'll only consider those observations which both have ones. So we have this variable, we have this variable, we have this variable. So we have three cases where both of the observations are one, both of the variables are one. Both of the observations are one for a particular variable, right? So that's going to be our numerator here. That's 3. Then this will be divided by all the variables except the ones that where we have both zeros. तो हम सिर्फ वो consider करेंगे जहाँ पे we have at least one case जहाँ पे एक one आ रहा हो, right? So we have one case here, we have one variable here. So first variable, second variable, जो 0 0 वाला case है, we're going to ignore that. The third case, the fourth case, fifth case, sixth case. We have 6 total values. So यहाँ पे जो Jaccard coefficient होगा, that's going to say that's going to have a value of 3/6. So this gives us 0.5 as the result, and this gives us 0.7 as the result. And there are different scenarios जहाँ पे आप matching coefficient use करेंगे, and there are different cases जहाँ पे आप Jaccard's coefficient use करेंगे. So ये तब use होगा when both 1 and 0 have the same value, and Jaccard's coefficient is going to be used when when you know from your data kit the observations are only going to be classified as similar when they're both ones, and they're not going to be classified as similar when they're both zeros. तो उस केस के अंदर हम Jaccard's coefficient use करेंगे. ठीक है? Does that make sense? Any questions on these two measures? या काफी commonly देखेंगे? इसमें क्या problem? Let me look at the chat. Okay, so I hope it's clear.
So, sir, shouldn't we ideally use Jaccard's coefficient instead of a matching coefficient?
It really depends. So let's say आपके पास जो है एक ऐसा variable है which can take different values, where you cannot really say कि one is more important than the other. So let's say आप जो है हम यूनिवर्सिटी एक सर्वे करती है where we are asking people कि आपकी जो है preferences क्या होंगी in terms of courses, ठीक है, in terms of types of courses, या फिर let's say हम short courses offer कर रहे हैं to people outside the university. So we may ask them, Kecha, what type of courses you would prefer. So let's say there could be one category that is coding courses. There could be another category that would be, let's say, so let's say हमारे पास सिर्फ दो categories हैं. One is coding courses and the other is non-coding courses, right? Now, we cannot really say that one is more important than the other. We might have both. We might say both of them are equally important. We need to understand about both of them. कि अच्छा non-coding जो है, that's also equally important. We could have some courses that come in that category, and we might actually be thinking of offering those courses as well. So we need to understand both of the cases. So वहाँ पे one does not have more weightage as compared to the other, or यहाँ पे matching coefficient would work better than the Jaccard's coefficient. So it really depends on the context.
Yeah, okay, that makes sense. Thank you.
Acha, no, this says the random coefficient. Okay. Then in many cases आपके पास जो है दोनों measures होती हैं आपके पास. So you use this matching coefficient and Jaccard's coefficient when all of your data is either categorical or binary. In many cases, you have some sort of a mixed data जहाँ पे आपके पास दोनों numerical measures भी होती हैं और categorical variables होती हैं. Now, it's a bit mathematically intensive. So what I would say is, in the interest of time, all you need to know about this is that there's a measure called Gore's similarity, and this you would use when you have mixed data जहाँ पे दोनों variables important है, numerical भी important है और categorical भी important है. In clustering you often use this in cases like this Gore similarity measure. ठीक है. In terms of what you'll do in practice, you will just your algorithm would give you an option कि आपने कौन सा distance measure use करना है. जब आपके पास दोनों measures जो हैं they're like uh, of both types and they're both important, तो आप जो है Gore similarity जो है वो use करेंगे. ठीक है. You can try to go through the slide and also go through this the chapter numbers written here if you want to understand this in detail. आप वो देख सकते हैं, but for our purposes here आप जो है इतना बस ध्यान में रख लें, when you have both measures, both types of measures, you would be using a measure called Gore similarity measure. ठीक है. I want to move on here and come to how you can actually measure similarity of different data clusters. ठीक है. So पहले हम क्या देख रहे थे, जो similarity और distance measures हमने देखी हैं, they are basically for measuring similarity or distances between different observations, right? अब यहाँ पे हम देख रहे हैं how we can measure similarity between different data clusters instead, right? अब यहाँ पे भी I would say you do not really need to go into what exactly these notations mean here. Just remember the names from here and I'll show you graphically कि इनका क्या मतलब होता है. ठीक है. That's what you need to understand. So one is called minimum distance, इसको हम single linkage भी कहते हैं. Another is called maximum linkage, maximum distance, इसको हम complete linkage भी कहते हैं. I'll show you graphically what each of these mean. Then you have some two other measures. One is called average distance and another is called centroid distance, right? So you have four different types of distances when you're talking about similar distance between different clusters. Now, let's look at this this thing here. Let me increase the size a bit. Okay. So let's say you have two clusters here that are appearing on your screen here. एक आपके पास ये जो dark वाले areas हैं, ये जो France है, Portugal. So you have this dark shaded areas. Let's say these are two different clusters. ठीक है. अब इनके दरम्यान में you could have many different points here. ठीक है. You could have thousands of points that lie in this cluster. You could have many points that lie in this cluster. Now let's see what different types of distance measures you can use. ठीक है. Now the first thing that we saw earlier was called minimum distance. जिसको हम single linkage भी कहते हैं. What it means is कि दोनों clusters के दरम्यान में जो है both of the clusters have many points, right? The minimum distance is going to be कि जो कोई भी दो points जिनका जो एक दूसरे से सबसे ज्यादा करीब हैं from these two clusters. So for example, in this case, इस France cluster के अंदर जो सबसे एंड यहाँ पे बॉटम लेफ्ट पे जो पॉइंट आ रहा है एक, और यहाँ पे दूसरे क्लस्टर के अंदर जो आपके पास टॉप राइट पे एक पॉइंट आ रहा है, दे आर क्लोजेस्ट टू ईच अदर, राइट? तो इनके दरमियान में जो डिस्टेंस होगा, दिस इज कॉल्ड मिनिमम डिस्टेंस. सो दिस इज वन वे ऑफ मेजरिंग डिस्टेंस बिटवीन क्लस्टर्स. ठीक है. That's called minimum distance या single linkage. Another way to measure the distance between clusters would be, देखिए ये एक ग्रुप ये है, एक ये ग्रुप है, ये है जिनको हम clusters कह रहे हैं. The other way could be you look at 2 points from the clusters that are furthest away from each other, right? So you have this point here and you have this point here. These are the 2 points from these two clusters जो सबसे ज्यादा दूर हैं एक दूसरे से. This measure is called maximum distance. ठीक है. So आप ये भी use कर सकते हैं. ठीक है. This is another measure that is used. Another could be that you first find out the centroids for both of these clusters. What centroid means is कि let's say आपके पास यहाँ पे 1000 different points है फ्रांस cluster के अंदर. आप क्या करेंगे? You will average all of those 1000 points. ठीक है, उन सब की average find करेंगे. That's going to be somewhere here. इसको हम कह देते हैं centroid, इस वैल्यू को, इस पॉइंट को, ठीक है, जो उन सब की एवरेज आएगी. इसी तरह दूसरे क्लस्टर में जितने पॉइंट्स हैं उन सब की आप एवरेज का फाइंड करते हैं और ये आपके पास एक पॉइंट आ जाता है. दिस इज द सेंट्रॉइड ऑफ दिस अदर क्लस्टर. अब जो इन दोनों के दरमियान में डिस्टेंस होगा, इन दोनों सेंट्रॉइड्स के दरमियान में, दैट्स कॉल्ड सेंट्रॉइड डिस्टेंस, राइट? दिस इज आल्सो अनदर मेजर दैट इज यूज्ड. एंड द फोर्थ टाइप वाज द एवरेज डिस्टेंस. Now, average distance would be कि let's say आपके पास यहाँ पे so let me actually reduce the number of points to make it easier to understand. Let's say आपके पास यहाँ पे अभी जो points show हो रहे हैं ना, let's say these are the only points that you have. So you have 3 points in this cluster जो आपके पास यहाँ पे show हो रहे हैं, and you have 3 points in this cluster, right? Average distance क्या होगा कि आप इनके सारे pair wise distances calculate करें. So essentially what that would mean is, okay, sorry, what happened there? Yes. So आप यहाँ पे क्या करेंगे? You are going to look at all of these distances. So you're going to look at this distance from this point to this point. You're going to look at this distance. You're going to look at this distance, and then you'll find out this distance here, this distance here, this distance here, and then you have this one here. तो आपने सारे पॉइंट्स को दोनों क्लस्टर्स के साथ के दोनों क्लस्टर में जो पॉइंट्स हैं उनको आपस में ज्वाइन कर देना, राइट? एंड यू फाइंड ऑल ऑफ दीज डिस्टेंसेस. सो इन दिस केस दोनों के अंदर 3 और 3 पॉइंट्स हैं, तो टोटल यू गोइंग टू हैव 3 times 3, 9 डिस्टेंसेस. इन सारे डिस्टेंसेस को फाइंड करके यू गोइंग टू कैलकुलेट द एवरेज. दिस इज कॉल्ड द एवरेज डिस्टेंस, राइट? सो ये आपके पास 4 डिफरेंट टाइप्स ऑफ मेजर्स हैं that are used in practice. And you'll see the maximum distance and this average distance, these are the ones that you will see most commonly used. So this is how you can measure distances between different clusters. Okay, now let's come to the actual algorithms. So there are 2 types of clustering algorithms that we're going to discuss. One is hierarchical clustering and the other is k-means clustering. Okay, I think we'll only be able to do hierarchical clustering today. So let's start with this. Now, in hierarchical clustering, it's very useful because इसके अंदर you do not really have to specify कि आपको कितने clusters चाहिए eventually. So whatever data, so let's say you're talking about customer segmentation. Let's say you do not have any idea कि आपको कितने जो है वो different groups बनाने हैं, क्या करने हैं. You do not know anything about that, right? Initially, ठीक है? आप बस देखना चाह रहे हैं कि अच्छा आप सारे different clusters आप try करना चाह रहे हैं, then you want to see के which one of them looks to be the best. आप जितने भी number of clusters जो हैं वो optimal आपको नजर आते हैं, आप वो जो है choose करते हैं. So initially you do not know कि आपको कितने groups में divide करना है, right? So now this is how the algorithm is going to work. So जितने भी आपके पास data points हैं, you're going to consider all of them as a separate cluster. ठीक है? You're going to consider all of them as separate clusters. So let's say you have 100,000 points. You would have 100,000 different clusters. ठीक है? All each, अगर आप customer data है, so each customer is a cluster in itself. ठीक है? So 100,000 customers है, तो 100,000 आपके पास different segments है. Now, of course, it's not very useful, but we'll see how this will work after that. अब आप single cluster से आपने अब उनको जो है उन 100,000 clusters को जो है combine करते जाना है, and you'll keep on combining until you have only one cluster left, and that would be कि आप उन सारे 100,000 customers को एक single cluster में जो है वो डाल देते हैं, right? So we start from 100,000 clusters, अगर आपके पास उतना data है, and eventually all of this would come down to only one cluster. And of course, somewhere in the middle, you're going to choose कि अच्छा कहाँ पे आप cut off point लगाएंगे कि आपको इतने clusters चाहिए, right? And how does this work? आपके पास जो 100,000 initially clusters होंगे, you're going to keep merging the clusters that have the smallest distance between each other. So आप 100,000 अगर आपके पास observations थी initially, आप हर observation का बाकी 99,999 values के साथ distance find करेंगे, and you'll see which of those distances is the smallest. उनको आप merge कर देंगे, and then you'll have 99,999 segments, and you'll repeat the process, right? You'll repeat the process again, और आप फिर देखेंगे कौन से clusters जो हैं अब उनका जो है smallest distance है, और फिर आप उनको combine कर देंगे, and you keep repeating the process. So let's look at this visually like this. अब इसके अंदर remember आप कोई भी distance measure वो use कर सकते हैं. You may be looking at minimum distance, maximum distance, average distance, or the centroid distance. You could be using any of them. Let's look at this visually how it really works. So let's focus on this left graph for now. So you have 6 different points. ठीक है, इसको हम visually देख सकते हैं अभी, because अभी हम सिर्फ ये assume कर रहे हैं कि हमारे पास सिर्फ 2 variables हैं. You have one variable on the x-axis here, you have another variable on the y-axis here. ठीक है, इससे ज़्यादा हो जाएंगे तो we'll not be able to visualize that. But this is how essentially what happens behind the scenes in this algorithm. So you have 6 data points here. Okay, 1, 2, 3, 4, 5, 6. Initially, you'll say each of these is a separate cluster. So you have 6 points, 6 observations. So you have 6 clusters. So you'll start like this. You will say, आप देखें कौन से which points have the minimum distance. So in this case, you see these 2 data points, 1 and 2, they have the smallest distance between them. So you're going to make combine them into one single cluster. ठीक है, आपने 1 और 2 combine कर दिए. So now you have 5 clusters. So you have 1 cluster here. You have 2, 3, 4, 5 clusters left. ठीक है. Now also look at the right figure here. जो आपके पास right side पे यहाँ पर नजर आ रही है. You see के we'll eventually हम end पे देखेंगे, हम इसको use करेंगे to figure out कि हमें कितने clusters जो है उसमें divide करें finally. But let's look at how this figure is actually building. So आपके पास यहाँ पे on the x-axis you have the different points given, और जब आप एक cluster को combine कर देंगे, you will show this on this other figure in a way कि जो आप ये जो height है यहाँ पे, this represents the distance between those 2 clusters. So let's say यहाँ पे this is the value of the distance that these 2 clusters have. तो ये उतनी आपकी यहाँ पे height हो जाएगी between these 2 points. तो आप ये इस तरह से join कर देंगे इनको, and this height will represent the distance between these clusters, right? So now you'll repeat the process. You'll see कि अब ये जो 5 clusters हैं, अब इनमें which clusters have the smallest distance from each other, right? So in this case, we are actually using the average distance. ठीक है, average distance की basis पर हम इनको combine कर रहे हैं. ठीक है. So in the next step, it turns out कि जो 3 और 4 हैं, ये clusters, these are closest to each other. तो आपने इन दोनों को combine कर दिया. Right, so now we have 4 clusters, 1, 2, 3, and 4. So you've also shown that same thing here. जो 3 और 4 के दरमियान में distance था, you have shown that here on the other diagram, right? In the next step, it turns out कि ये वाला जो cluster था 3 और 4 जिसमें किए हुए थे, जो green cluster है, that is closest to this other cluster, that was this point here. हमने इन दोनों को combine कर दिया, right? So we show the same thing here in the figure कि इस cluster को हमने combine कर दिया इस 5 वाले के साथ, and we have this joint here like this. So now we have 3 clusters. In 3 clusters में देखेंगे which two are closest to each other, and do the same again. So it turns out this red cluster and this 6 here, they were closest to each other. So these are also combined now. So आपने यहाँ पे ये भी show कर दिया यहाँ पे इस figure के अंदर. ये आपका y-axis पे show कर रहा है कि कितना distance था उनके दरम्यान में. All right. And finally, we have 2 clusters here. So in the next step, we can also join them. So we have 1 cluster left. हमने यहाँ पे दूसरे figure में इसको भी join कर दिया. This figure here, ये जो right side पे show रही है, this is called a dendrogram. और जो आपको output मिलेगी आपके clustering algorithm के बाद, that's going to be this dendrogram at the end. ठीक है? और इसकी basis पर आप decide करेंगे कि आप कितने जो है वो eventually clusters choose करते हैं. You started from 6 clusters, and eventually you have only 1 cluster left here at the end. ठीक है? Okay, yes, Taha, the complexity is very high. That's true. So it's n square, but still it's polynomial times. So it still will work even though it takes a lot of time. Okay. So for large data sets, it is going to be very costly. That's very true. The other algorithm जो हम k-means clustering वाला करेंगे, that's also going to be costly, लेकिन it's going to be relatively less as compared to this one. So वो I think the complexity of the other algorithm is relatively low as compared to this. But yes, it is n square, and it will take time for large data sets. So that's why what you do is कि आप जब past data को आप cluster कर लेते हैं, when a new data point comes, you do not calculate all of those clusters separately. आप जब एक दफा से clustering ये कर लेते हैं, for new data points आप सिर्फ देखते हैं कि अच्छा which cluster is it closest to, आप सिर्फ उस पे वो assign कर देते हैं. आप real time में ये clustering नहीं कर रहे होते, you do it periodically. So for example, maybe let's say after a week or so, you have a significant additional number of customers. तो आपको लगता है कि आपकी segmentation शायद थोड़ी सी different हो जाए. Then you'll maybe run this algorithm again once, and then it may you may keep it to be the same for the next week or for the next month, जो भी आपने period जो है वो assign किया हुआ है. So for every new customer, it's not going to recalculate itself. The recalculation will only be periodic because of the cost. अच्छा, now let's look at this figure here जो dendrogram है. अब इसमें देखें जब 1 और 2 हमने combine किए थे, they were fairly close to each other. 3 or 4 they were also fairly close to each other. But after that the jump is fairly big. जो आपको next जो आपने breakdown किया, उसमें this cluster here 3 or 4 वाला जो cluster था और 5 cluster, इनके दरम्यान में जो distance है, that's fairly high as compared to what we had earlier. ठीक है, so ये आपको इतना ज़्यादा जो है ऊपर जाके फिर ये combine हो रहे हैं. And then इसके बाद जो next step है, उसमें भी आपका ये distance जो है थोड़ा काफी जो है increase हो गया इस point से. There's a huge jump here, and then you have a single cluster at the top. So this dendrogram is going to show you कि आप जो different clusters को combine कर रहे हैं, उसमें कितनी cost है, कितने different clusters को आप एक दूसरे के साथ combine कर रहे हैं. Because remember, the goal in clustering is that you want कि जो एक cluster के अंदर सारे points हैं ना, they are as similar to each other as possible. and जो different clusters हैं they are as far from each other as possible, right? So एक cluster के अंदर जो points हैं you want them कि वो जितने ज़्यादा similar हो एक दूसरे से, the similar as the more similar they are the better it's going to be. So अगर आप ये for example इस case के अंदर 6 और ये 1 2 को combine करते हैं, you see कि इनके दरम्यान में काफी ज़्यादा distance है. So you'll have to decide whether this distance is too much for you or you are willing to accept this. So it's going to be your decision. So अगर let's say आपको 2 clusters चाहिए, ठीक है? अगर आपको 2 clusters चाहिए, तो आप क्या कर सकते हैं? This will be one cluster 1 2 and 6 इस point तक, and the other cluster could be 3 4 and 5. अगर आपको 3 clusters चाहिए, so basically what you will do from the dendrogram is कि आप horizontal lines draw करेंगे यहाँ पे. So if you draw a line here, let me do it like this. So let's say if you were to draw a line here like this, that's going to divide your observations into different clusters. कि जहाँ पे ये कट कर रहा होगा ना, जितने पॉइंट्स पे कट कर रहा होगा उतने आपके क्लस्टर्स बन रहे हैं. So यहाँ पे इस यहाँ पे हॉरिजॉन्टल लाइन आप ड्रॉ करते हैं, that gives you 2 clusters. One cluster is these points and the other cluster is these points here. अगर आप यहाँ पे एक लाइन ड्रॉ करते हैं, you get 3 segments, right? So 1 2 and 3. अगर आप थोड़ा सा नीचे ड्रॉ करते हैं, you get 4 segments. 1 2 3 4. So it's going to be a decision based on the context कि आपको eventually कितने clusters चाहिए वहाँ पे, उसकी basis पर आप जो है वो decide करेंगे, और कितना ज़्यादा जो है वो distance एकदम जो है jump मिल रहा है. So essentially what you want is as few clusters as possible, which give you the most information as possible. So again, these are two conflicting goals. कि आपको number of clusters जो है minimum चाहिए, and you want के they give you as targeted and as more targeted information about the different clusters as possible. ठीक है? That's what the goal is going to be. So we're going to stop here because we are out of time now, and we'll continue from here in the next session. Hierarchical clustering जो है वो तो हमने यहाँ पर cover कर लिया. This figure is called dendrogram, and I've shown you कि हम किस तरह से जो है number of clusters जो है eventually जो है decide कर सकते हैं based on the distances, right? We'll talk about the different advantages and disadvantages in the next class of hierarchical clustering, and then we'll move on to k-means clustering. So we'll stop here, and those of you who want to leave, you can leave, and I'll be answering questions here from now.
सर ये आप दूसरी क्लास मंडे को ही रख रहे हैं फिर?
Yes, it's going to be Monday same time, 12 o'clock.
सर एकेडमिक से हमें एक मेल आई थी, वैसे वो कह रहे थे सैटरडे तक आखिरी क्लासेस होनी चाहिए, तो मुझे लगता आपको रखने देंगे मंडे को.
नहीं, so in the business school at least we have until the end of next week. So अगर आपकी और भी कोई कोर्स की क्लासेस रहती हैं, we can do it until the end of next week. ठीक है? So Monday is going to be our last session, but I'm also going to offer an optional session after that, just to answer your questions. जो भी लोग attend करना चाहते हैं, अगर आपके कोई भी किसी भी part of the course में आपके कोई questions हो, हम उसमें वो address कर सकते हैं. That's going to be completely optional. We're going to be done with our 30 sessions on coming Monday, and that will be it. Okay. The next session, I might have it on Thursday at the same time. That's going to be optional. Okay. And remember, we're going to have quiz in the coming class on Monday. It will be at the end of the class, and you will need to know about k-mean, sorry, not k-means, k-nearest neighbors, and decision trees methods for that quiz. अच्छा, any questions?
सर चार्ट में क्वेश्चन पूछा हुआ है, मैंने आपसे यहाँ पूछ लेता हूँ कि साइकोग्राफिक और बिहेवियर सेगमेंट्स, उनको हम किस तरह डेंडोग्राम के थ्रू रिप्रेजेंट करेंगे, क्योंकि ये तो क्वांटिफाइबल मैट्रिक्स के ऊपर बना हुआ है, तो उनको कैसे करेंगे इस तरह?
I'm not sure कि आपका उससे मुझे साइकोग्राफिक डेटा से आपका एग्जैक्ट जो है वो क्या मीनिंग है?
सर के कस्टमर की इंट्रिंसिक मोटिवेशन क्या है, वो क्यों चीज़ खरीद रहा है, और बिल्कुल एब्स्ट्रैक्ट या फिर उस तरह के जो क्वालिटेटिव एस्पेक्ट्स होते हैं उसकी बेसिस पे आप क्लस्टरिंग कैसे करते हैं?
नहीं, सो दैट्स मोर गोइंग टू बी, वो तो फिर आप का जो है आपका जो सर्वे, अगर आप सर्वे के बेस पर कह रहे हैं, दैट्स गोइंग टू बी बेस्ड ऑन द टेक्सचुअल रिस्पॉन्सेज जो आप, और वो उसको अगर आप क्वांटिफाई नहीं कर सकते हैं एज सच, you cannot do it like this. So this is more quantitative clustering. तो जो qualitative variables हैं जिसमें जो है let's say you're doing some interviews, जो है उसकी बेसिस पे आपके क्वालिटेटिव सेगमेंट कर रहे हैं, that's a different thing. हम वो चीज यहाँ पे कवर नहीं कर रहे हैं. वो अगर आप क्वांटिफाई नहीं कर सकते किसी चीज को, you cannot do it here. अगर यहाँ पे आप at least what you should be able to do is to categorize that. अगर आप categorize कर सकते हैं उसको, then that also works. You can convert that into dummy variables and include that in this. लेकिन अगर आप उसको categorize भी नहीं कर सकते और वो completely abstract है, then we cannot do anything about it in these algorithms at least.
Okay.
But what you can do is कि आप जब ये clustering कर लेते हैं, so let's say you are able to cluster your customers into, let's say, 5 different segments. तो आप उन 5 segments को फिर आपने एक तरह से understand करना होता है कि वो किस basis के ऊपर जो है वो groupings हुई हुई हैं. So you try to understand कि अच्छा वो different customers जो हैं उन वो let's say आपने जो भी segment किया आप उनको किस तरह से कोई नाम दे सकते हैं. For example, if they are low value customers, high value customers, whether they are customers who like to purchase at a certain time, whether they are customers who like to purchase a certain category of products. तो आप वो देखेंगे, उसकी basis पर you'll see कि अच्छा whether you can relate some of those behavioral aspects to one of those clusters or not. या तो आप उसको वो भी फिर एंड पे आपकी क्वालिटेटिव जजमेंट होगी. एल्गोरिथम का पार्ट वो हम नहीं कर सकते unless you can quantify that. So the bottom line is, unless you can quantify anything or you can categorize them into different classes, you cannot include them in these algorithms. So that's why you also have many qualitative approaches in marketing. You must have studied those in your marketing courses, at least if you had it with Dr. Atik or someone else. तो वो आपने वहाँ पे cover की होंगी, but we do not deal with them here.
Yes sir, हमने पढ़ी है सर. One more thing, कितनी कैटेगरीज यूजुअली बनाई जाती हैं, मतलब ऑन एवरेज कोई इसका कोई नंबर है?
नहीं, there's no single answer to that. So it really depends. अगर आपके customers जो हैं वो, you have an online store, let's say Amazon है, they could even do, let's say 50, 60, 100 segments. So it might be suitable for them to make so many segments because उनके customers जो है इतने ज़्यादा हैं. लेकिन अगर आपके पास एक आपकी जो है वो you have a smaller retail chain and the number of customers that you have is, let's say, in tens of thousands, you might want to have a less number of customers, maybe 8 to 10. So it really depends on.
नहीं सर, मैं पूछ रहा हूँ कि वो जो आपने कहा ना कि क्वालिटेटिव डेटा की कैटेगरीज बनाई जा सकती हैं और फिर उसके ऊपर उनको डेंडोग्राम से कर देते हैं. तो अगर हम क्वालिटेटिव डेटा, उसका मैं पूछ रहा था उनको कितनी उसकी कैटेगरीज पे बनाना फीजिबल है, या फिर डमी वेरिएबल जितने मर्जी बनाते रहे कोई इशू नहीं होगा इसमें. तो अगर मैं 15 कैटेगरी बना रहा हूँ, 10 बना रहा हूँ, तो क्या कितना मेरा आंसर रेडिकली चेंज हो जाएगा इस?
So again, there's no single answer to that. You should try as few categories as possible. ठीक है, जितनी कम होगी the better it is, but of course you also want to capture the different information those categories are. So if 2 categories are very different और इसमें बहुत सारे customers fall कर रहे हैं, you would not want to combine them. But if there are some categories जिनमें बहुत ज़्यादा customers नहीं हैं and there is some way कि they are similar to some other category, you may want to combine them. So ideally you would want as few categories as possible, but of course you do not want to lose information as well. So again, these are 2 conflicting goals और आपको दरमियान में कहीं पे fall करना पड़ेगा.
Yes sir. Sir, as an optional reading, I'm emphasizing the word optional here very much. आप segmentation के ऊपर कुछ भेज सकते हैं material?
So we have, I've already uploaded a lot of books there. जिस और ये आपको यहाँ पे अगर आप देखें at the start of each section you have these references. जब जितना भी हमने जो भी चीजें मशीन लर्निंग में कवर की हैं, you have all of these references here, जो आप जाके you can refer to them.
They'll cover segmentation based on dendrograms और किस तरह वो dummy variables बनाते हैं ना, और उसका भी क्या?
Yes, it covers all of that. और अगर आप थोड़ा सा ये some of these is going to be slightly more, let's say, mathematically intensive, और आपको जो है आप you may want to just skip those parts as well. आपको ज़्यादा जो focus होना चाहिए ना, it should be on interpretation, कि आपने ये algorithm run कर लिया, how can you you know and how do you understand कि अच्छा क्या चल रहा है in let's say ओवरऑल आपको आइडिया होना चाहिए कि ऑलमोस्ट किस तरह से एल्गोरिथम वर्क करते हैं, उसके रिजल्ट्स जो आते हैं उसको हम किस तरह से अंडरस्टैंड कर सकते हैं. ठीक है, आपको बहुत ज्यादा जो है मैथमेटिकल डिटेल्स में जाने की जरूरत नहीं है.
ओके सर.
उस पर्सपेक्टिव से जो एक और बुक अपलोडेड है जो हम पहले भी यूज करते रहे हैं, दैट्स द बिजनेस एनालिटिक्स बुक. जो उसमें जो है ना ये थोड़ा सा ब्रीफली किया हुआ है और इन एन इजी टू अंडरस्टैंड लैंग्वेज. तो वो उसमें वही चैप्टर है जो हमने मार्केटिंग एनालिटिक्स में भी किया था. आई थिंक इट्स चैप्टर 10, नहीं इट्स चैप्टर 4, जिसमें आई थिंक इट्स अबाउट डेटा माइनिंग. उसका चैप्टर का नाम शायद आई गेस डेटा माइनिंग है. इट्स चैप्टर 4 और चैप्टर 5 देयर. You may want to read that whole chapter. जो बहुत आसान words में ना उसमें explain किया हुआ है. That would be the starting point, and once you're done with that, you can move to these sections in these books here.
Okay sir, thank you.
Okay.
Sir, quiz MCQs based है?
Yes, MCQs.
सर मेरा अटेंडेंस
Sorry, मुझे आवाज नहीं है आपकी.
सर मेरे अटेंडेंस के बारे में एक क्वेश्चन है. हम जो सीएस के लोग थे.
अच्छा Javeer, please hold on for a second. Just an announcement before other people leave as well. Please make sure that all of you have that a PowerSoft recorder working before the next class. Okay, you should have it working. You should have tested it on your computers as well. Make sure that it works for you. आप कुछ डाउनलोड करना है वो आप डाउनलोड कर चुके हो, और आपने जो है उसको रिकॉर्डिंग को ट्राई करके आपने जो है वो टेस्ट भी कर लिया. It's the same one that we used last time as well. I would recommend that. The Apple users, you can use the other option as well, जो I guess Azhar ने last time recommend की थी. I think it was called Loom. आप वो भी use कर सकते हैं if you want. But you should have the recorder working for you before the next class. Make sure that you test it as well. ठीक है, ये आपने next class से पहले जरूर करना है. Okay जी, Javeer, could you please say that again? Attendance के बारे में क्या पूछना है आपको?
सर हम सीएस के लोगों ने ना कुछ काफी देर बाद ज्वाइन किया था, 5 सेक्टर्स के बाद. तो हमारे 5 एब्सेंट हैं.
Sorry, अच्छा आपकी 5 absences हैं?
जी सर, और बाकी सीएस के लोगों की जिन्होंने बाद में ज्वाइन किया.
जिन्होंने क्या किया?
मसला नहीं है, जिन्होंने बाद में ज्वाइन किया था.
जिन्होंने बाद में ज्वाइन किया था. ओके,
अगर तो कोई मसला नहीं है तो ठीक है, लेकिन अगर 5 एब्सेंट से वो एकेडमिक्स मसला करती है तो फिर आप काइंडली ठीक कर दें. उसके बाद हमारे यहाँ भी है.
ओके, ऑलराइट. उसके बाद तो आपने ऑनलाइन क्लास तो कोई मिस नहीं किया?
नहीं सर, कोई नहीं.
Okay, so 5 absences is not an issue. So I guess there are 6 allowed, so that should be okay.
सर मुझे क्विज के बारे में बात करनी थी कि सर जो प्रीवियस ऑनलाइन जो हमारा क्विज हुआ था उसमें जो क्वेश्चंस थे वो बहुत क्लटर्ड थे. मतलब एक तो ऊपर से कैमरा भी ऑन था और ऊपर से क्वेश्चन इतने ज्यादा क्लटर्ड थे कि पढ़ा ही नहीं जा रहा था.
क्लटर्ड थे क्या मतलब?
सर इतनी लंबी, एक तो स्टेटमेंट्स भी लंबी थी, ऊपर से वो बिल्कुल साथ मतलब उन्हें स्पेस नहीं थी स्टेटमेंट्स में.
So yes, there was one question जिसमें issue था. Yes, I'll try to use something other than Google Docs this time. That might be helpful. So yes, I'll take care of that this time. But long statements उसका तो कुछ नहीं कर सकते. वो तो reading का तो आपको.
तो वो इस वजह से ज़्यादा भी लॉन्ग लग रही थी कि स्पेस कम थी इस वजह से. और
Okay,
सर
I'll
एक
try
ये
to
भी
have better formatting this time. Yes.
और सर एक ये भी बात है कि सर इस कोर्स का कंटेंट इतना ज़्यादा हो गया है कि अब समझ नहीं आ रही फाइनल में हम सब कुछ किस तरह से प्रिपेयर करेंगे। कंटेंट बहुत ज़्यादा हो गया है।
बहुत ज़्यादा किस तरह से?
सर मतलब इतने सारे कॉन्सेप्ट्स हैं एक तो, और बस हाँ ये कि कॉन्सेप्ट्स बहुत ज़्यादा और इतनी सारी चीज़ें।
हाँ, ये तो मैंने आपको स्टार्ट में बताया था कि द कोर्स कंटेंट इज गोइंग टू बी अलॉट, तो उसमें आपको एफर्ट थोड़ी ज़्यादा करनी पड़ेगी, लेकिन द थिंग इज कि all of these things are very important कि if you were to say to somebody कि आपको एनालिटिक्स कुछ पता है, तो you cannot really claim that unless you know these things. तो हम skip कर नहीं सकते थे. I would have wanted to reduce it a bit after the situation that we are in right now. But again, the feedback from the head of department and everybody else is that we cannot really compromise on the learning outcomes as such, because if you have studied this course and you have this on your transcript, you must be able to show that you know all of these concepts. तो इसके बगैर जो है you cannot really say that you know about analytics. So that's the issue. So हमें थोड़ी चीजें इस तरह से cover करनी थी. We have still I still reduced a lot of detail here. हमने इसके actual जो है implementation थी R में वो cover करनी थी. I've not done that. That's not going to be part of the final exam, लेकिन आपको assignment में फिर भी वो करना होगा, लेकिन उसमें I'll be giving you code snippets जो आप as it is जो है assignment के लिए use कर, जो project के लिए use कर सकते हैं, लेकिन आपका एग्जाम का पार्ट नहीं होगा वो. सो आई हैव रिड्यूस्ड क्वाइट अ बिट इन दैट रिस्पेक्ट, क्योंकि हमारे पास टाइम भी ज़्यादा, क्लासेस का भी कम हो गया थोड़ा सा, तो कोर्स कंटेंट कुछ
पहले
कम.
ये भी होता था, पहले हम मैथ्स दे चुके होते थे ना, प्लीज वो वाला पोर्शन
और
कंटेंट
सर आप
कवर हो चुका होता था.
नेक्स्ट क्लास में एक
क्या होता था
सैम्पल
सही?
पेपर भी दिखा सकते हैं फाइनली?
अच्छा सॉरी, could you please say one by one? जवेरी आप क्या कह रही थी पहले?
मैं कह रही थी कि पहले इतना पोर्शन कवर हो चुका होता था मिड का ना,
हेलो,
तो वो हमें प्रिपेयर करने में इतना मसला नहीं होता था.
ओके. यस ज़ैनब.
सर एक और भी ये बात करनी थी कि आप हमें नेक्स्ट क्लास में सैम्पल पेपर दिखा सकते हैं फाइनल एग्जाम का, कि मतलब जैसे हमने आर भी पढ़ा है, मशीन
सैम्पल पेपर तो as such मेरे पास नहीं है, because this is the first time that this course is being offered. There are no past exams as such as well, but again, it's not going to be anything that that you have not done in class itself. So I'll tell exact the format. मैं आपको format exact बता दूंगा कि क्या क्या चीजें जो है मैं expect कर रहा हूँ. तो वो I'll detail all of them in a post on Classroom sometime closer to the exam. लेकिन essentially आपके concepts जो हैं वो clear होने चाहिए. As far as machine learning is concerned, इसमें ज़्यादा जो focus होगा वो आपकी कॉन्सेप्ट्स पे होगा जो हमने क्लास में कवर किए हैं. इसकी इम्प्लीमेंटेशन हमने क्लास में नहीं की है, तो इम्प्लीमेंटेशन इज नॉट गोइंग टू बी पार्ट ऑफ द एग्जाम, लेकिन सारे कॉन्सेप्ट्स इंक्लूडेड होंगे. उससे पहले जो हमने किए हैं चीज़ें, फॉर एग्जांपल जीजी प्लॉट पे प्लॉटिंग वगैरह, और जो डीप लाइब्रेरी को यूज करके जो किए हैं, दैट्स गोइंग टू बी प्रैक्टिकल. यू हैव सम डेटा सेट जिसमें आपको जो है उन लाइब्रेरीज को यूज करके यू मे हैव टू डू सम फिल्टरिंग, सॉर्टिंग, या फिर मेक सम प्लॉट्स. वो आपको आर के अंदर वो प्रैक्टिकली करना होगा. उसमें जो है देयर आर नो कॉन्सेप्ट्स एज सच. उससे पहले जो है आपका एक जो है स्प्रेडशीट मॉडलिंग पे क्वेश्चन होगा, दैट्स गोइंग टू बी पार्ट ऑफ इट. और एक आपका जो है वो एक्सेल के ऊपर जो है you may have to do some things. You may do some analysis using pivot tables, pivot charts, etc. Acha, please exclude PowerPoint stuff we did in the start of the semester. Which stuff was that? Taha, sorry, I don't remember.
सर वो स्टार्ट में जो किया था पिवट चार्ट वगैरह ये जो चीजें थी ना वो वाला. सर वो ऐसे ना रटा ऐसा लगता है कि हमें मतलब पावर पॉइंट यूज करना आना चाहिए इस तरह।
पावर पॉइंट यूज करना आना चाहिए
मतलब जिस तरह के है कि हमने ऊपर ऑप्शंस में जाके यहाँ पे करेंगे तो हमारा डाटा इस तरह का हो जाएगा, मतलब हमें वो टूल्स याद रखने पड़ते हैं उसके लिए। वो जो स्टार्ट में हमने जो किया था ना 4-5 लेक्चर्स थे इस पे
एक्सेल।
हाँ जी एक्सेल वाला जो था मॉडलिंग से पहले पहले जो
मॉडलिंग से पहले एक्सेल में जो पिवट चार्ट्स और पिवट टेबल्स जो हमने किए थे उसमें वो तो आपको पिवट चार्ट्स बनाने पिवट टेबल्स बनाना उसमें तो रटा कुछ नहीं, उसमें तो यू हैव टू
जैसे वो आते हैं जो
सर वो स्किल बेस्ड चीज तो है, लेकिन वो फॉर्म पे आप कैसे चेक करेंगे, मतलब एग्जाम में किस तरह उसे चेक करेंगे, वो थोड़ा आइडिया फिर दीजिए।
चेक क्या करेंगे आपको, मतलब आपको कुछ एक स्पेसिफिक जो है आउटपुट आपसे रिक्वायर्ड होगी कि आपको ये एनालिसिस करना है और आपको वो चार्ट बनाना होगा उसका या जो है टेबल बनाना होगा। you'll be given specific instructions क्या ये आपको ये आउटपुट चाहिए।
तो वो बनाना हमने एक्सेल वगैरह पे ही होगा?
एक्सेल पे बनाना होगा बिल्कुल।
ओके ओके, फिर तो कोई मसला नहीं।
एक्सेल का तो कोई इशू नहीं बनाने का, इसमें तो कोई एरर्स नहीं आते, लेकिन आर के अंदर अगर हम कोड ना करें, ये डॉक्टर शाह भी आज ये कहते हैं कि सब्जेक्टिव पार्ट ऑफ द एग्जाम आप हैंड रिटन भी कर सकते, तो अगर ये वाला पार्ट भी हम हैंड रिटन करते हैं इंस्टेड ऑफ एक्चुअली राइटिंग इट ऑन आर, ताकि हमें डिबगिंग के इश्यूज ना फेस करने पड़े, क्योंकि आपको पता ही है हम जब भी इधर प्रैक्टिकली लैब्स जब हमारी हो रही होती थी ऑनलाइन, हमेशा किसी न किसी को इशू आ रहा होता है उसमें, वो 25-30 बच्चों के इशू भी आ रहेंगे, वो समझ नहीं आ रही कि कैसे रिजॉल्व होंगे फिर उसी बात।
नहीं लेकिन वो इश्यूज तो फिर आपको खुद रिजॉल्व करने होंगे ना, ये आपका जीजी प्लॉट और हमें सिर्फ आर के अंदर दो चीजें आपकी जो है वो टेस्ट होंगी जो हमने कवर की हैं। एक तो सिंपल डेटा फ्रेम्स में जो हमने सब सेटिंग वगैरह की है, इनफैक्ट 3 चीजें, सो डेटा फ्रेम्स में सिंपल सब सेटिंग वगैरह कैसे कर सकते हैं, ठीक है वो किया है, और हमने डीप लायर लाइब्रेरी को यूज करके कुछ फिल्टरिंग सब सेटिंग की है, और हमने जीजी प्लॉट को यूज करके कुछ प्लॉटिंग की है। अब उसमें अगर आपके सिंटैक्स के इश्यूज आ रहे हैं वो तो आपको खुद रिजॉल्व करने हैं ना, एग्जाम में वो आप पूछ तो नहीं सकते, उसमें डीबगिंग के इश्यूज तो वो आपको मैं हेल्प कर भी नहीं सकता उस टाइम पे। वो आपको देखना होगा, आप विल हैव एक्सेस टू द कोड्स जो हमने क्लास में किए हैं, वो सब आप यूज कर सकते हैं, साथ साथ यू डोंट हैव टू मेमोराइज एनीथिंग, बट यू शुड बी एबल टू एटलीस्ट चेंज देम अ बिट, और आप वेरिएबल्स चेंज कर दें उसमें से, एटलीस्ट दिस मच यू शुड बी एबल टू डू। तो उसमें
मैं
भी
इसलिए
कुछ
कह रहा हूँ उसमें बेहतर रहेगा कि आपको हमें कोई सैंपल क्वेश्चन दे दें और वो कोड के स्निपेट्स दे दें जो भी आने फाइनल के वक्त शेयर करना है, ताकि हमें पता चल जाए किस तरह उनको स्टैक करना है और फिर क्या क्या उनमें चेंजेस हमें कितनी को करनी आनी चाहिए।
ओके, सो आई बी गिविंग यू कोड स्निपेट जो हमने क्लास में सारे कवर किए हैं, ठीक है वो मैं शेयर कर दूंगा, लेकिन जो क्वेश्चंस होंगे देयर यू कुड थिंक ऑफ देम, यू कुड थिंक दे आर गोइंग टू बी वेरी सिमिलर टू द वंस दैट यू हैव डन ऑन डेटा कैंप, ठीक है उसमें हिंट नहीं होगी, हिंट विल बी कि आपको एग्जैक्ट आपको कोड्स पता है कि आपने उन्हीं में से आपको कोड को अप्लाई करने हैं, लेकिन आपको फॉर एग्जांपल जो है वो ये हो सकता है कि मैं आपको एक पिक्चर दिखा दूं या मैं आपको पिक्चर दे दूं एग्जाम में कि आपको ये चार्ट बनाना है, एंड देन यू हैव टू फिगर आउट कि आप वो चार्ट कैसे बनाते हैं, राइट, दिस कुड बी वन थिंग, एंड द अदर कुड बी कि जिस तरह आपको जो है एक दो वेरिएबल्स हैं उनके दरमियान में मैं कह दूंगा कि आपने क्रॉस टैबुलेशन करनी है यूजिंग जीजी प्लॉट, ठीक है उसमें आपने जो है वो फिर आप क्रॉस टैबुलेशन करनी है यूजिंग डीप लायर, या फिर आपने जो है वो क्लस्टर्ड जो है वो बार चार्ट बनाना है यूजिंग जीजी प्लॉट। So these could be the types of things that you have to do, but again जितना इम्पोर्टेंट ये है कि आप वो चार्ट बनाएं, उतना ही इम्पोर्टेंट है कि आप उसको फिर इंटरप्रेट कर सकें कि वो चार्ट आपने बना लिया उससे आपको क्या समझ आ रही है, जो चीजें हम पिवट टेबल्स पिवट चार्ट्स में भी हम करते थे कि हमने एक चार्ट बना लिया उसको अंडरस्टैंड करना कि व्हाट डज इट रियली मीन, दैट्स इक्वली इंपॉर्टेंट। तो आप सिर्फ इस पे नहीं फोकस करना कि अच्छा वो चार्ट बनाना कैसे, इन एडिशन टू दैट शुड आल्सो बी एबल टू अंडरस्टैंड कि उसका क्या मतलब है, उससे क्या समझ आ रहा है आपको, वो भी आपको एक्सप्लेनेशन देनी होगी इसके साथ।